Hi viewer, this is EasyElimu channel. I'm Vincent Kanwai. I'll be your teacher for today and I'll be guiding you through matrices from Form 3 Mathematics. Welcome. Today we shall start with the introduction. Under introduction, we know most of the informations which are in numerical form are mostly given in tabular form. As in, we may find some of the information like those which are represented in football matches or collected data in various ways like time keeping. We may have others differently. All of them may be represented in tabular form, but we can still make them simpler by representing them in matrix form and make it much more simpler. But let's see some or consider some of the information which are represented in tabular form. For example, we may have Barclays Premier League table and see how it is represented in table form and also how we can represent it in matrix form. For example, you may be issued with a Barclays Premier League soccer table in the second week of February in a certain season. We may see it like it has team. Then we have another column that is play. Won, drawn, then lost. Let's consider one of the table to be in that form, in a tabular form, in that we have a Barclays Premier League table, which may be also called as English Premier League. This is the Barclays Premier League table in the second week of February in a certain given season. So they played games for the first selected teams was as shown above, and it was as this with the number of played games. These are the played games, the number of games which each team won, and here we have a draw, here is a loss, and the points. Here, if game is played and a team wins, then it is entitled to 3 points per each win. And if it draws, it has 1 point. And if there is a loss or if a team loses, then it has no point award. Let's see another table that is a certain, we shall consider as Ramadan table for a given session that is in Nairobi, Mombasa, Nakuru, and Kisumu, how it was handled. So I'll be considering that Ramadan session, Ramadan timetable. Now it will be for Ramadan. Here we may start with Nairobi. This is Ramadan timetable session for different given towns in Kenya. That's Nairobi, Mombasa, Nakuru, and Kisumu. And here we are being given a closing time and opening time. We shall also consider another one, having a dosage, recommended dosage for treatment of malaria, and we shall now be considering it as a tabular form. Recommended dosage treatment. So I just call it dosage treatment. Here I have drawn 3 tables for three different activities. For the first table here, it shows us the information on teams which played in a given season. That was on February, second week of February in a given season. And we saw that the team, after playing, we have found that they played this number of games. These are games played, number of teams which the games it won, then the draws, lost, and the points of that team. Now, we have seen another table here, that is a Ramadan table in Kenya for a certain year, and we can find out that given the towns, we have different closing times and opening times, and are given as we can see. Now we have another dosage treatment table for the treatment of malaria, and we can see for the days we have first day after 6 hours, second day, third day, and then others over 15, 11, and is given as below. Now, after having understood this all tabular information as it is represented, we can represent this information in matrix form. And therefore, we can now form a matrix and know that if this one is a number of games played, this is number of games which the team won, the draws, lost, and points, we can represent them in a matrix form and find a singular, one matrix which has all this information and omit the headings of the information. So long as we understand the headings, we can omit the headings and represent our information in a matrix form. Like, for example, this for football or Barclays Premier League information, we shall just say in Barclays of Barclays Premier League, and we just represent the first here, we just put it the way it is, that is 8, 7, 8, 7, 8. Then followed by 5, 5, and the next row is 3, 2, 1, 2, 4. We write the way it is. That's 3, 2, 1, 3, 3, 2, 1, 2, 4. The next one is 0, 0, 2, 1, 1. And the last is 18, 17, 16, 14, and 13. This information here, if you understand the headlines in the table, you can still interpret this information. And the way we do write a given number of system as in this condition or given rule, like this one, and we enclosed in bracket, we refer to that as a matrix. Now, from this, we can identify that the first row here, after having understood there, we can identify this one represents the number of games played. This one is representing the number of games which the team will win or won. This one will represent the number of teams, the games which the team drew or drawn. And then this one will be the number of games which the teams lost. These are the points per each game. Now, you can use the same and find out if that one gives out the truth. And the same, we shall see how we can calculate out and see what we can find out. And the same can apply to Ramadan timetable, whereby for that of Ramadan timetable, we can have a matrix for Ramadan timetable. Then, having understood these headlines, like Nairobi, Mombasa, Nakuru, and Kisumu, we can still represent it in a tabular form and represent this closing time and opening time. Let's just put here to be PM so that we can omit this side and here be in AM. We can still represent that one in terms of a table and say it will be in form of, because we know it starts with Nairobi, Mombasa, Nakuru, then Kisumu. After understanding the headline, we can just represent as 5, then 6, 39, 4, 51, 6, 24, AM, 502, and the other one is 643, 507, and the other one is 648. We can find the table is represented in that kind of form, and that of dosage treatment table matrix. After understanding it well, the headlines, we can still omit them and write them in a matrix form, and we shall form a matrix of the form 4, 2, 2, 2, and then 3, 1, 1, 0, and here form 2, 1, 1, 0. Here, this one here is a matrix for the table of dosage treatment, or the treatment of, or application of dosage treatment to malaria. Now that is the table which I have formulated, and the other table here is for the Ramadan timetable. This one is given in time. The first one is in PM, the second one is in AM. Here we understand this is over 15 years, 11 to 15, and this one is 6 to 10. After understanding the information or the headlines, we can still omit them out and give our information in a matrix form. We have seen if you arrange your information in such a way that it looks the information which I have given out like this, then that information will be in a matrix form. But here it is in tabular form. So meaning that our information can either be represented in tabular form or be even given in a matrix form. Now we have this matrix form, so we can use it as an example and calculate out and see if the points are really correct. So we know this is the number of games played, and here we have the number of games which the team wins, and here is the point awarded as 1 for the draw. So we can calculate and find out if it is 18. Actually, if you take 5 plus 3, you will find out that the games played is 8. And if you take 5, that is 5. Take 5, multiply by 3. You add 2, 3 multiplied by 1, then plus 0. You will find out it is true, it is giving you 18. And for the next case, if you take 5 plus 2, you will get 7 games which the team played. And if you take 5 multiplied by 3, 3 is 3 points awarded per every win, and 2, you add to 2 multiplied by 1, and 1 here is a point which is awarded to every draw, and plus 0. So you are going to get, this one is going to give you 15 plus 2, you will get 17. The same applies to the others, and you will find out that is how you will find what you have. So in short, we have represented our information in matrix form. So let's go on and see how we can represent further and see what does this matrix entail more of it. Let's now learn more about matrix, and we are going to learn about order of matrix. Under this order of matrix, we shall refer to what does it mean when we refer to order of matrix. For example, in our previous session, we saw that dosage treatment for malaria matrix gave us 4, 2. There is what we found with that of dosage treatment for malaria. We found out that it gave us this kind of matrix. If we refer to a matrix, order of matrix, the first thing we do consider here is what is in a matrix.
As you can see, there are some numbers which are arranged in vertical position. As you can view, you will find that we have numbers which are in a vertical positions, and we have some which are arranged in the horizontal position, in that they form up a column and they also form up a row. If I talk about a row, is this. They form a row. So they form rows, and also we have verticals, which are this one. So these verticals, we do refer to them, as columns. And then the horizontal ones, which we are seeing horizontal ones which are in the other direction, we refer to them as rows. And each term which you identify here, each of the term in between here, like 4, 3, 2, 2, 1, 1, they are referred to as, it may be a letter or anything, they are referred to as elements of a matrix. So in short, what we are going to do here, we are going to consider which kind of, or what order does we refer to if we have a certain matrix. For example, for our case here, we have referred to verticals, which we said is the horizontal, the vertical lines here, they will be referred to as columns, and the other ones are rows. So in case we have these verticals, we can give them a number like n. Let them be as any number. For our case is 3. We can see there are 3. So we are having, for our case is 3. And here the horizontal or rows, let us give them then and say they may be m. So that one be represented by, we are having 4 of them. So if you need to assign any matrix or give its order, it is normally given by the number of rows and the columns is consist. And that is the order of that matrix. For example, for our case here, we start in giving the order of a matrix, we do start with the number of rows, then we give with a combination of the columns. And it is normally written with a multiplication sign to mean that is the number of rows considered with the columns. So it will be, for our case, the order of our matrix here will be, we are going to give the number of rows first, which is 4. As you can see, we are having 4 rows. Then there are 3 columns. So our matrix is of 4 by 3. If you write this one, is read as 4 by 3. And if you are being asked what kind of order of that matrix is, so as we can see, you find that the order of this matrix is 4 by 3. You can identify several of them. You can take one of the, for example, I may give you A, B, C, or just give you A, B, C, D. And from this we can identify, we are having 2 rows and also 2 columns. So we can refer to this one as a matrix of 2 by 2. Because we are having 2 rows, then 2 columns. So we are having 2 by 2. And this one is of order 2. We can see 2 by 2. Actually it's of order 2 by 2. And we can have several of them, like A, B, C, D, E, F, H, I, J, K, L. You can even have that one. This one here, we are saying we are having 3 number of rows. Then we having 4 number of columns. So this one is of order. It is of order 3 by 4. So that is how we assign orders to given matrices. In general, we can say that if we're having a matrix which has m number of rows and n number of columns, then that matrix will have an order of m by n and is read as m by n. That is the order of that matrix. Let's continue and see more about matrix in our next session. Let's see more about order of matrix, and now we are going to consider elements of a matrix. Under elements of a matrix, we can consider them and say that any kind of any letter or numbers which are in a matrix are always referred to as elements. We can have like A, B, C, D, and this one be a 2 by 2 matrix. We shall find out that A, B, C, D, that is, if it is A, is an element of that matrix. B is also an element of that matrix. Be it like numbers, for example, you may give 5, 6, even 8. Let's say you're having that kind of a matrix. And if that is your kind of matrix, this matrix here, we can see is a square matrix of 3 by 3. And from there you can find 2 is an element of that matrix, 4 is an element, meaning that any number located in that matrix is an element of that matrix. The same applies to if it is letters. Any letter located in a given matrix is an element of that matrix. And if you need to find the position of any of them, then it is given by stating the number of row in which it lies and also the number of column at which it lies. For example, we may have another one like A, B, or just let's use S. Now to assign, let's just have a short output that to assign the position of each matrix or each element, then this one we know it is located at the first row and first column. This one is at the first row and second column. This one first row, third column. The same applies to this one. Second row, first column. Second row, second column. Second row, third column. And this one is third column, first row. So it will be third row, first column, third row, that is third row, second column, third row, third column. So that is how we do assign the position of a given element in a matrix. So if you have been asked, find the position of number 6 in this matrix, then you shall state it is located at, it will be 6 at 2, 2. So if you want to find it, you will come at the second row, then you look at the second column. You will find there is where you will position your 6. So meaning that if we want to assign positions to given elements in a matrix, then it will be, if it is A, it will be A11, A12, A13. If it is 3 by 3 matrix, for example, we are going to have A21, A22, A23, A231, A32, A33. So this is what we are going to have. Each of the numbers which we have here are representing the number of rows, and the next is number of columns. So in giving position of a given element in a matrix, we do state its position by first stating the number of rows in which it lies, then you give the number of columns in which it lies. And they are normally subscripted to that given number. You can see I'm writing downwards so that to indicate that are the positions of that numbers. We have seen for that example, and I may even give you a matrix, for example, like aren't you using the same information to view this matrix? That's 5, 6, 4. Now, as we can view this matrix here, you will find out that it is having 4 number of rows. And from those 4 number of rows, we are going to have 3 number of columns. So meaning that its order is of 4 by 3. Then I want you to give me the position of element 8 and position of element 0 and also the position of element 6. I want you, using the same information which we did here, I want you to use that same information and give out the position of element 8, position of element 0 and that of element 6. So in general, we can say that if Aij, if we needed to state the location of A, and we have been told that A is of Aij as an element of a given matrix, then that means that this A lies in ith row, meaning that is the number of row in which it lies, and it is located also in jth column. So if you are stating the position of that element A, and you find out you are being given it is Aij, then know that it lies in the ith row and in the jth row. And we can see that if you have a matrix and you will find out that the number, when the number of rows, we said the number of rows are represented by letter M and the number of columns are represented by N. So if you are having that M is equal to N, you will find out that that matrix is forming a square matrix. And that one can be identified, for example, like a 2 by 2 matrix, whereby we can use even letters A, B, C, D. This is a matrix of which it is having 2 rows and 2 columns, so meaning it's a 2 by 2 matrix, meaning the number of rows, which are M, are equivalent to the number of columns, and that is what we refer to as a square matrix. It may be even a 3 by 3 matrix, in that you may have A, B, C, D. This one here, we are having a 3 by 3 matrix, in that the number of rows are equal to 3 and the number of columns are also equal to 3, giving us a 3 by 3 matrix. That is the order of that matrix. But we can see that as from that one, we can say M is equal to N, and that one is a square matrix. The same we can have a matrix which has zeros as the elements of that matrix. Everything in that matrix is 0. That matrix is referred to as null or zero matrix. A matrix, and you may find that that matrix, you want to denote it. For example, you may be told this A, B, C, D matrix is represented by letter A. So you may be given A. You will find out that in case we need to denote any given matrix, they are always denoted by a capital bold letter. So if you are denoting any kind of a given matrix, it is denoted using a capital bold letter. And if you may find out that you want to make an assumption, or you have to make a relationship between one and another matrix and see if they are same, you will find out that in case I have a matrix A, which is equal to A, B, C, D, and I have another matrix here, B, and I be told that this matrix is A, B, C, D, then I will say the two matrices are the same. Two matrices are the same only if the elements in each of them are equal. The elements of the matrix are equal, in that if it is A, it is both A in the two matrices, they are the same. And also, if they belong to the same order. For this one, we know it's a 2 by 2, and this one is also a 2 by 2 matrix. So they are of the same order, and the elements in them is also the same. So that we have known how these matrices are behaving, and we now want to go and explore more with addition and subtraction that's working with the numerical signs on the matrix. Now let's see addition and subtraction of matrices, and we can see that matrices can be added or subtracted only if they are of the same order. And with that we can do add or subtract two or more matrices so long as they are of the same order. And in addition and subtraction of given matrices, we do them by summing their corresponding values. If it is, for example, A, B, C, D, and I have another one like we are adding to C, D, let's say it is E, F, G. If we are adding, we can see this is a 2 by 2 matrix, this is a 2 by 2 matrix. So condition 1 is fulfilled. So meaning that they are of the same order, they are compatible. So if that the case, then we can do sum, and in summing, we do take the corresponding elements is what we sum. Like for example, here we are going to take A plus E, that is 1, and then we shall have another one, A plus E, then B plus F, and the other one will be C plus G, the other one is D plus H. That is what we sum. So you will find out after summing, you are going to have this kind of a matrix. This is for summing. And if it is subtraction, then here the signs will change and become subtraction. As we can see, let's go on and use some of the given numerical examples here and see how it works out. For example, if P equals to, P here is equal to 254,073, and Q is equal to 138,625. We have been told calculate P or find out P plus Q and also P minus Q. Let me ask class, to which order does these two matrices belong? You will find out that the first matrix is having 2 rows and 3 columns. The second one is having 2 rows also by 3 columns. So both of them, they are of 2 by 3 matrix. So if that's the case, then it means we can do sum them together because they are compatible and they are satisfying that they are the same. So if we do take, that is 254,073, we add it to 138,625. 8, 6, 2, 5. Then this one will give us something of P plus Q, of which this one is our P, this is our Q, and that one is going to give us, you are going to take 2 plus 1, I mean it will be 2 plus 1, 5 plus 3, this is 4 plus 8. Here we are going to take 0 plus 6, here is 7 plus 2, and here will be 3 plus 5. If you do that one, you will have found P plus Q. And this one is going to give you P plus Q, you will find out it is 2 plus 1, you are going to get 3. Here 5 plus 3 is 8. 4 plus 8, you're going to get 12. 0 plus 6, it will be 6. 7 plus 2, you're going to get us 9. And here will give you 8. So it means that if you take P plus Q, you are going to get 3, 8, 12, 6, 9, 8. That's what you will find. Let's see, what if you subtract? What if you take P minus Q? What do you get? You will write whatever you have in here. That is 2, 5. The value of the matrix P, which is 2, 5, 4, 0, 7, 3. Then we are going to subtract 1, 3, 8, 6, 2, 5. And on subtraction, we do subtract the corresponding elements. So, if we are going to subtract the corresponding elements, we shall find out that we are going to have 2 minus 1, 2 minus 1. That's for the first part. Then we shall have 5 minus 3. So, will be 5 minus 3. We shall have, the next one is 4 minus 8. So it's 4 minus 8. Then 0 minus 6. So here is 0 minus 6. And here will be 7 minus 2. So that is 7 minus 2. The next is 3 minus 5. So there is 3 minus 5. So whatever you will find here is what I will refer to P minus Q. And it's going to be 2 minus 1. You will get your answers 1. Here is going to give you 2. Here will give you negative 4. Here will be negative 6. Here 5. And here you will get negative 2. And that is your answer if you take P minus Q. We have seen when you are given two matrices and you are being asked to find P plus Q, for example, the sum of them together, you have seen how you do. You just add the corresponding elements and you find your answer. If it is subtraction, you also do the same. You subtract the corresponding elements. And for example, let's see another example which include both of the signs together. If given that kind of a matrix and you have been told if A is that, B equals to that, and then C is what we see there, find A minus B plus C, A minus B plus C, and also find out A minus, now this one is B, for B is A minus B plus C, which are bracketed. So, what you will do here, I will just guide you and you're going to find it out by yourself. Here what you are going to do is, as they are, you will just use them the way they are. For example, here you will write the matrix of A, then minus that of B, minus that of C. In case, for example, if it is a line, here let's say it's like minus here plus, you will go to have that will be, for the first corresponding element will be 3 minus 2 plus 8. So it's going to be 3 minus 2 plus 8. That's the first element. Next element will be 2 minus 4 plus 0. So this one will be 2 minus 4 plus 0. The next one will be 1 minus 1 plus 2. So it's 1 minus 1 plus 2. That is the first row of the three of them together. Then the second row will be, now you're going to take this 0 minus 1 plus 1. As you move on, do it out and find what you will find out as the final answer. Then here, as you understand from board maths, we understand those which are in bracket first are performed first, and then we do give it the other priority after performing them. So whatever we shall do here, you will take that of A, for example. You are going to work out first that of B plus C. So you will take that of B plus C first. After getting the answer here, you now take A minus that answer. Whatever you will find is the answer for the three of them. So we are going to see another one which has missing letters. We need missing numbers represented by letters, and we need to find them. Use the methods which I have shown you to work out whatever is here. So you are going to work out this example here. It's a little exercise for you to see if you have understood. So work out this and also work out for this as I have directed you. In some cases, you will find you have been issued with. Now here, we are being asked to find the missing numbers which are represented by the letters. So what you will do here, you are going to use the same method which I show you. And here, if you do that, you will find out the given numbers. For example, I will take A minus 9. You will find out that if you take a negative, you minus another negative, you will find negative minus another negative, which will give you positive. So meaning this one is a multiplication, negative multiplied by negative, you will get positive. So meaning that it will be A plus 9, and that one will be corresponding to negative 3. And here you will have B minus 5. B minus 5 will be corresponding to 4. And C minus 2. C minus 2. Let's first work out the left hand side. 14 minus 7, you are going to get 7. So it will be 14 minus 7 for here. And here will be D minus 1. So we are going to have D plus 1. Here will be 7 minus 7. So it's 7 minus 7. And here we are going to have E minus 10. E minus 10. Here is 14 minus 8. 14 minus 8. 2 minus 13. 2 minus 13. We can see, after doing this, whatever we find on the left hand side should be equal to negative 3, 4, 8, 7, 2, 0, 36F. This is what we should find out. So what we are going to do, we are going to let as we just have. So you will find that if you take A plus 9 is equal to negative 3, so meaning that we can find the missing values. And if A plus 9 is equal to negative 3, then it means that A is equal to negative 3. If you subtract 9 from both sides, you will find it's negative 3 minus 9. So you're going to get your A is equal to negative 12. So that is how we find. And then for the B, will be B minus 5 is equal to 4. B minus 5 is equal to 4. So if you add 5 on both sides to eliminate B on the left hand side, you are going to get that your B is going to be 4 plus 5, and that is B is equal to 9. If you want C, it will be C minus 2 is equal to the corresponding element, and that is 8. If you want to find C, you need to eliminate negative 2. And if you eliminate, you will add 2 on both sides, and you will find your C is equal to 8 plus 2, and this one is equivalent to 10. So that applies to even 14 minus 7. 14 minus 7, we find 7. Corresponding element is also 7. That's okay. D plus 1, we are going to get D plus 1 is equal to corresponding element is 2. So if we need D, subtract 1 from both sides, and we shall find D is equal to 1. So the same applies. 7 minus 7, corresponding element is 0. E minus 10 is equal to corresponding element is 30. So if you need E, you are going to add 10 on both sides, and you will find your answer is going to be 40. So meaning E is equal to 40. 14 minus 8, you will find 6, and the corresponding element is 6. 2 minus 13, we are going to get negative 11, and the corresponding element is F. So meaning that F equals to negative 11. So we have found the corresponding elements, and with that, I have no doubt that given any sum or subtraction of any kind of given matrix, so long as they have the same order, you can be able to handle any problem you have been given. If it is a problem involving missing numbers, you can use whatever is provided to find out what is missing. Let's now view or see how we can find matrix multiplication. And here we have been given A is equal to 0, 1, 2, 1, 3, 1, 2, 1, 4. This is a matrix A, represented as that form, and we have been asked to find 3A. We have been given a scalar multiplied by that matrix. So we want to see what we can find out if we are being given that case. So what we are going to do here, if you are being asked that question, is like you are being asked, if you are being told to find 3A, this means is 3 times the matrix A. If that is the case, then it is the same as doing A plus A plus A, meaning that we are going to sum up the matrix A 3 times. So if you do that, you're just getting out what you will have. So it's like you are going to get 0, 1, 2, 1, 3, 1, 2, 1, 4. Then we sum to another one of the same, 0, 1, 2, 1, 3, 1, 2, 1, 4. We add to another A, which is 0, 1, 2, 1, 3, 1, 2, 1, 4. So if we're going to sum up, it's like we are finding 3A. So if we sum up, you will find the first element is going to give 0. Next one will be 1 plus 1, 2 plus 1, 3. So this one will be 3. 2 plus 2, 4, 4 plus 2, you're going to get 6. 1 plus 1, 1 plus 1, you'll get 3. Then this one will give you 9. Here, 1 plus 1 plus 1, you will get 3. Here you're going to get 2 plus 2 plus 2, you will get 6. 1 plus 1 thrice is 3. 4 plus 4 plus 4 is going to give you 12. So we are getting that is our answer there. So if you are being asked to find 3A, you will find that it's like taking A plus A plus A. thrice, so we have the answer as this. Let's see if that is the true. In case we have 3, we need to multiply it by 0, 1, 2, 1, 3, 1, and 2, 1, 4. This is a scalar unit, and we need to multiply it with our matrix and see what it will give us out. For example, if we multiply the first quantity, entry will give us 0. The next entry is going to give us 3, and this one 3 by 2. You multiply the scalar unit with every of the element in the matrix. So if we multiply that way, you are going to get, this one will give you 6. 3 by 1, you will get 3. 3 by 3, you will get 9. 3 by 1, you are going to get 3. 3 by 2, 6. 3 by 1, 3. 3 by 4, 12. So that is how we find that one. And as you can view, you will find out that the two matrices are equal. They are similar and same. So that is how we find out that one. And we can conclude with that if in general you have been given a matrix A, B, C, D, E, F, for example, and you be told to find, if this one is B, and you have been asked to find KB, then it means it's the same as taking this matrix B, you sum them K times. But to avoid that tediousness, we have seen just simpler. You just take KB, and that one is the same as just taking K into A, B, C, D, E, F, such that it will arise up by the entries into each multiplied by that scalar unit, which is now KB, KA, KB, KB, KC, KD, KE, and KF. That is what we found out. So without getting tedious or tiring yourself, we are saying you can use just that small procedure and find out whatever you are seeking for. So we have seen how you can find it out, and with that we have come to a conclusion of that, of a scalar unit multiplied by a matrix. I'll give you an example. I want you to go and work it out. If B is equal to 2, 3, 1 and 1, 0, negative 1, I want you to find 5B. That one is for your case. Go and find out how you can find that 5B. And in case of a negative, I want you also to find out negative 3B. Find out and see how does it change whatever you have. But use the same procedure which I told you. It's like just having K into B, and so that if you are having K as a scalar unit, you multiply it through the entire matrix with every element in the matrix. So you will find out what you will have there. So use that procedure and work out that example. Let's see with another examples how we can consider some others. Here we are having a Kenyan league. Consider a table below of a Kenyan league in a certain period of a year, and we are having, now we are being informed that this is a Kenyan league in a certain period of a year, and we have been given a team like Tusker, FC Leopard, and Lane Stars, with together the number of games which it won, drawn, and lost. And another information is that for every win we have 3 points, draw is 1 point, and loss is 0 points. So having that, we can calculate the total points of each team using matrix method. And for example, we can write this information we have seen earlier. Having understood it, we can now write it as a matrix because we have understood the headings and omit the headings from it. So we can have 19, 11, 6, and here 19, that is, the first one is for Tasker, so that is what I'm writing, 19, 9, 8, 9, 8, and then the other one is 14, 8, 12. So that is how the matrices are. But we have been told for every win there is 3 points, every draw is 1 point, and every loss is 0 points. So we can represent that one also in a matrix form, and we shall see it is 3, 3, 1, 0. So it shall be 1 representing for a draw and 0 for a loss. So this is another kind of matrix. And with that, we can now work out and find what we can see as the total points of each team. So here we know the first row represents Tasker, 19 represents number of wins, and draws are 11, and the second column, the third column here represents the teams which it loses or lost. And this one is our working or the point matrix. So we are going to work out and see the points by each team. We shall start with the first one, like Tasker. If we need to know the points which Tasker owes, then we are going to multiply this or to work out this way. In the multiplication of matrix, we consider this. The first thing we do consider in which order do they lie. We only multiply if the order may be compatible. That meaning that for this case we are having 3 by 3 and this one is 3 by 1. So as you can see, this order is compatible. We can multiply the 3, and after multiplying out, you will find that in case this is 3 by 3 and this one is 3 by 1, you will find your answer will have 3 by 1 orders because it will take this and that one. If, for example, you are having a matrix, the first matrix is n by n, and you are multiplying it with n by p, order of n by p, then we can see these ones are compatible, meaning they can be multiplied together, and your result shall take m by p order. So it will have m by p order. So meaning for our case here, whatever we shall be finding as the result, it will have m by p, meaning it will have 3 by 1 matrix. So let's see what we shall find out. And right there. So we have seen they are compatible, so we can multiply. So meaning that in multiplication, another thing in multiplication, if you need to multiply matrix, we do consider you take each row, you multiply by column. So the corresponding column. So if you need the values of this row, you multiply. If there are 3 rows here also, 3 by 3 matrix, then it could be the first row with the first column, or you go that way, first row, first column to get this value here. If the second, I will show you with the time. Let's first work with what we have here. So for example, this is our case here. We are going to take 19 by 3. That is 19 by 3. We add 2, we continue 19 by 3, 11 by 1. So 11 by 1. Then we add to 6 by 0. That is 6 by 0. And we shall find out that this one is going to give us 68 points. So this one is 68 points. And then for the other row, this second row, it will be now for the team of FC Leopard. For FC Leopard, it will be 19 by 3. Now we don't multiply by 1, 0. We start with the row and then column. So it will be 19 by 3. So that is 19 by 3. 9 by 1, we are adding 9 by 1, that is how we work out, and then 8 by 0. And you will find this one will give you 0. 19 by 3 is 57, so we are going to add to 9. And you will find out your answer here is going to be 66 points. So the next is 14 by 3. That is 14 for... We are now finding the marks for... Actually, the points for Ulinzi Stars. And if it is for Ulinzi Stars, we shall now have 14 by 3. This 14 by 3 is the number of games which were won. Then 8 by 1, because that is a draw, so 8 by 1. And then the last one is 12 by 0, because in laws there is no point awarded. So we are going to add 12 by 0. And we will get, this one is going to give us, actually it's giving us 50 points. So from there we can see, we have worked out and found is 68, 66, and 50. Meaning that here we can now give out our answer and say that if we do that, we are going to have another matrix here which will be 68 for the first row. Second one is 66, and the last one is 50. If we put together, this is what we shall get. So as I told you earlier, this was a 3 by 3 matrix. This is a 3 by 1, but our result here is taking 3 by 1, meaning what? If this one is Mn and this one is Np, then our result takes M multiplied by P. Then this one is equal to M by P, and that is what we have seen there. So that is how we work out, and we can see how you can use it to compute different kinds of problems and give out solutions if they are related to what we have done here. We shall see much more of them as we go on. Now let's consider another example here. We are having an example 2, and it reads, as a kiosk owner wanted to buy 1 debe of potatoes, 3 bunches of bananas, and 2 baskets of onions. He went to Uhuru Market and found the prices as 280 shillings for a debe of potatoes, 50 shillings for a bunch of banana, and 100 shillings for a basket of onions. At Harambee Market, the corresponding prices were 300 shillings for a debe of potatoes, 48 shillings for a bunch of banana, and 80 shillings for a basket of onion. Now the questions are, express the kiosk owner requirement as a raw matrix, and also B, express the price in each case, in each market as a column matrix, and C, use the matrix in A and B to find the total cost of each market. So what we are going to do here, we are going to see what we have been told. So we know for debe of potato, that is for a debe of potato, a debe of potatoes, we have told he wanted to buy 1 debe is equal to 1. Then 3 bunches of banana. Now bunches of banana, we wanted to buy 3. And how many baskets of onion? We have 2. Baskets of onion. We have been told we wanted to buy 2 of them. So from there, we have been told to express the kiosk owner's requirement as a raw matrix. The requirements are these, what we have here. So we need to express them as a raw matrix. What we are going to do here, since we have understood whatever we have in here, we shall know that if we express them in a raw matrix, it means that we are using only 1 row. So it will be 1, 3, 2. And here with this matrix here, it is in a row matrix whereby the first identity here represents the debe of potato, and this next here is the bunches of banana, and the other one is basket of onion. With this one is what we are referring to a row matrix. So we have finished expressing the kiosk owner's requirement as a row matrix. And next you will be asked by express the price of each market as a column matrix. Now it is as a column matrix, not a row matrix. So you have understood that we have two markets. We have that of Uhuru market and we have that of Harambee market. For Harambee market is different. For Uhuru market, we were told the corresponding of depth of potato, let me just represent it by P. Depth of potato, we found that it will be 280 for depth of potato is 280, but we have only one depth, so we are going to multiply by 1 and find our price is 280. Now for the bunches of banana, we have been told it costed 50 shillings and we have in 3, so we shall represent it by letter B. And we say it is 3 multiplied by 50 and we shall get this one is going to give us. Actually, let me first, before doing that, let's just give out what we have. So let's just give per debe of potato, we have been told is 280. And for a bunch of banana is 50. And that of basket of onion, we were told is 100 shillings per each. So basket of onion, we are going to have as 100. Now for Harambee market, we are going to have Harambee market for potato, we have been informed is 300 shillings per debe, and then 48 shillings per bunch of banana, and the last one is 80 shillings for basket of onion. So for basket of onion, here should be onion, is 80 shillings. So we have that. Then we were asked to express the prices in column matrix. So since we have understood, we can give it in column matrix as 280, 50, and 100, and should be in a column matrix. The same to this one will be equivalent to 300, 48, and 80. This is what we refer to a column matrix. And this one is a row matrix. Then another question asks, use the matrix in A and B to find the total cost in each market. For example, for this one, what we are going to do here, we shall pre-multiply each of the cost per each item with the number of items which we bought. So we are going to pre-multiply, and in that pre-multiplication, we are going to work out at this point. Our row matrix we know is 1, 3, 2. So we shall do this. We are going to get 1, 3, 2, and we know this is representing the number of items the kiosk owner bought at Harambee and Uhuru market. Then the first column matrix, let it represent the prices at Uhuru market. And we shall have another one, which will be the prices at Harambee market. So as we can see, here this one is a 1 by 3 matrix, and this one is a 3 by 1 matrix. The true matrix, even this one is a 3 by 1 matrix. If you can see the two matrices or the three matrices are compatible, because as you can see, this one is 1 by 3 matrix, 3 by 1 matrix, so meaning this one here can be compatible. The same here, a 1 by 3 and this 3 by 1, we can see they are still compatible. So you can multiply because 3 and 3 can go together, but your matrix will end up having 1 by 1. So meaning just a single unit. So we shall work out and see how that single unit comes about. Let's see. Now on working it out, we are going to have, remember in multiplication we said we do take row, then we multiply by the corresponding column. So what we are going to have is 1 multiplied by 280, and we shall get 280. And this one is 3 by 50. Actually, it's 1 by 280. It will give us that one. And then we shall add. Let's just do as we should do it. So it is 1 by 280. 1 by 280. Then we add 2. 3 by 50. 3 by 50. Then we add 2 by 100. 2 by 100. So that one will give us, that is 280 plus 150 plus 200. You are going to get, this one is going to give us 630. So for Uhuru Market, this was for Uhuru Market. Now for Uhuru Market, we are getting, the total cost there that was spent is 630. Let's work for Harambee Market, and we shall find this 1 by 300 plus the other one is 3 by 48 plus 2 by 80. So it will be 2 by 80. And you will find that that one you are going to have 604. It's less. So we are getting 604. And actually from our matrix, you can view out, it was a 1 by 3 multiplied by 3 by 1 matrix. And we said our answer had to be a 1 by 1 matrix. And we have found it's a single unit in each case. In each case, for Uhuru Market is a single unit, which is 630. And for Harambee Market, we are getting is also a single unit, which is 604 shillings for Harambee Market in each case. So we have found. But remember, in multiplication, whatever you should first consider is this compatibility of a matrix. So let's see another one. If we have a complicated. Now I'll give you another one. I want you to work out this. This is your test scale. I want you to work out this. I'm going to give you, consider a matrix A and B such that A is equal to and B is equal to 325, 410, and we are having 672. Then I have asked you to find AB. Find AB. What you should do here, I will just give you a hint. And if you are being asked to find AB, what you should do first, identify if the two matrices are compatible. If they are compatible, then you are free to work out as we were working out. For example, this one, it is having 2 rows, then 3 columns. Here, it is having 3 rows, then 3 columns. So this one is a square matrix of 3 by 3, and this one is 2 by 3 matrix. So with that, we can see that this is a 2 by 3, and this one is a 3 by 3. So from there, we can see that the two matrices are compatible because they can be multiplied together, and our resulting matrix will have a form of 2 by 3. So what you will find out will be in form of a 2 by 3, like this one, but that is your result. So it will be a 2 by 3, but what you are going to multiply is 2 by 3 and 3 by 3 matrix. So you will have that one. Note that in each row is multiplied by each column, and then the ith row, for example, if this one is the ith row, I'm going to multiply this row here by my jth row. That is what I was telling you. If this is the ith row, then I will multiply this one ith row by the jth column. So we have seen in order to multiply any kind of a given matrix, it must be compactable. So we can say that in general, given a matrix of the order Mn, as I have told you, if you have been given a matrix of the order M multiplied by n, that is M by n, and another matrix of order n by p, then the two matrices are compactable if you are multiplying them because n and n are close and they are similar. So meaning that matrix will take, the resulting matrix will take a matrix of the order m by p. This is what we'll take. This one is for testing compatibility, and your resulting matrix must take m, actually it should be m by p. So it will take m by p. That's what you should know in general. Let's test what if we are having two matrices like A and B, and then we are asked to find AB, and somebody doesn't find AB, find BA instead of AB. What will happen? Let's see. In case we have a kind of matrix like this, and you are being asked to find AB, then that means on finding AB, we are going to take a row multiplied by a column, and this is a 2 by 2 matrix, this is a 2 by 2 matrix, meaning that our resulting matrix shall take 2 by 2, and it will be 2 by 1 plus 1 by 4, so it is 2 by 1 plus 1 by 4, that is for the first entry. Then the other one for here now, or for next for here, it will be 2 by 0. Now this is how we do multiply. If you need an entry at this point, you take this row, multiply by the first entry of the next matrix. Then if you need an entry on this point, you take also the first row, you multiply by that column of that, the next entry which you want at the next matrix. So that one will give you 2 by 0, then plus, that is 1 by 1. Then we are going for another one, which is at this entry here. So if you need this entry now, you are going to take the row of that entry, multiply by the column of the first column on matrix B. So it will be now 1 multiplied by 1, and then 3 multiplied by 4, plus 3 multiplied by 4. The same applies to every kind of matrix which you will be multiplying. May it be 3 by 3, 4 by 3, or 4 by 4, it will depend. The case applies to any of them. So if you need an entry that will be at this point for this matrix here of AB, then you are going to take the whole row multiplied by the next column. So it will be 1 by 0. So 1 by 0. Then we add to 3 by 1. So 3 by 1. You are going to get, this one here is AB. So you will find 2 by 1 is 2, plus 1 by 4 you are going to get is 4. 4 plus 2 is going to give you 6. So here is 0 plus 1, you will get 1. And here 1 plus 12 you are going to get is 13. And here 0 plus 3 you will get 3. So meaning that if you take AB, you are going to get is that. But what if you want BA instead of AB? What will you find? So that one we are going to take 1, 0, 4, 1. Then we multiply by 2, 1, 1, 3. So I can put there a multiplication sign or I deny it. But if they are bracketed and close to each other, you know it's a multiplication. So if we do that case, then we are going to have 1 by 2 then plus 0 by 1, and entry on this point here will be 1 by 1 plus 0 by 3. At the lower side, it will be 4 by 2 plus 1 by 1, and the other side will be 4 by 1 plus 1 by 3. So that is what we are going to have, and this is a matrix of BA, and if you work out that way, you are going to get 1 by 2, you will get 2, plus 0, you are going to get 2. So 1 by 1, 1, plus 0, you will get 1. And here 4 by 2 is 8, 8 plus 1, you will get 9. 4 by 1 is going to give you 4, 4 plus 3 is 7. So as you can check out, you will find that the two matrices are not the same. This is for BA, this is for AB. For that person who was asked to calculate or to find the multiplication of A and B for the matrix A and B, and worked out BA instead of A and B, you will see that they are totally different. So meaning that we can conclude that in working AB, in case you have been given a matrix AB, then it is not equal to BA. So never should you interchange when working out. Work out as the condition as you have been provided with. So if it is AB, work out AB. If it is BA, work out BA, and not interchange. Let's see identity matrix. And here we are going to consider some given examples of identity matrix, some examples of matrix, and then from there we can view and understand what do we refer to when we say identity matrix. For example, we may have an example on like A equals to 1, 4, 2, 3, and B may be equal to A, B, C, D, and you be told pre-multiply each of them with an identity or with a matrix, not an identity. Pre-multiply each of them with a matrix of 1, 0, 0, 1. Pre-multiply each of them with that. So if we pre-multiply by A, then we pre-multiply by B, we shall find that of A will give us, if we do that, we are going to get is 1 by 1 plus 0 is 1. Then if we need a point, this of the other side is 1 by 4 plus 0 is 4. Then 0 by 1 plus 2 is 2. Then 0 by 4, 0 plus 3 is 3. So we can find is giving us the same. It's still giving us A. This was A and it's still giving us A. Then we can do for B, that is 1, 0, 0, 1. You will find out that it's going to give us of B is A, B, C, D. Let's see of this. What should we get? 1 by A is A plus 0, A. 1 by B, B plus 0, we are going to get B. 0 by A plus C is C. 0 by B plus D, we are going to get D. So we are finding it is only mapping itself to another. Actually, we are only getting the same identity which we had. That is B, and that is for A. So we have found the same. Let's see for another matrix. Let's take another matrix like P, which is 4, 2, 1, 1, 3, 5, and this one be 0, 2, 1, 1. And maybe another one as Q, which is A, B, C, D, E, F, G, H, I. So this one, all of them. Let's pre-multiply each of them with a matrix of 1, 0, 0, 0, 1, 0, 0, 0, 1. So let's multiply each of them by that. Pre-multiply each of them by that matrix and see what does it get. So we shall have 1, 0, 0, 0, 1, 0, 0, 0, 1, and see if we pre-multiply by 4, 2, 0, 1, 3, 5, 2, 1, 1, what do we get? You will find 1 by 4 plus 0 plus 0, you are going to get 4. 1 by 2 plus 0 plus 0, you are going to get 2. 1 by 0, 0, plus 0, plus 0, you will get 0. Next, we are going for the next. So it is 0 by 4, 0, plus 1, plus 0. We are going to get 1. 0 by 2, plus 3, plus 0, 3. 0 by 0, plus 5, plus 0, 5. 0 by 4, plus 0, plus 2, 2. 0 by 2, 0, plus 0, plus 1, 1. 0 by 0, 0, 0 plus 0, 0, plus 1, 1. So we are getting the same thing. We are just getting our P back. We just go P back. So that was for the P. Let's see for Q. What shall we get? In case it was Q, which has no numbers. So we shall find out that if we pre-multiply by that one, if we pre-multiply Q by A, B, C, D, E, F, G, H, I, you are going to get 1 by A plus 0 is A. 1 by B plus 0, you are going to get B. 1 by C plus 0, you will get C. The same applies to the others. 0 by A, 0, plus D plus 0, D. Then it goes through entirely, and you are still getting the same whatever we had there. So, meaning even Q is the same. So here P, we got it the same, and Q, we have got the same to A and also B. So from there we can say that a matrix which when multiplied by another matrix, you will still get the same matrix which you used. As for this case, we use this kind of matrix and we pre-multiply it. We pre-multiply A by it and we still got A. For B, we pre-multiply with it, we still got B. The same as applied to that of P and Q with respective of the matrix, and we still get the same. We do call such matrices as identity matrix. So we can say that an identity matrix is actually a square matrix. We can say that an identity matrix is actually a square matrix which has ones in the leading diagonal, and I will show you which one is the leading diagonal and the main diagonal. For the case of 1, 0, 0, 1, the leading diagonal is this one. Is what we are referring to, the leading diagonal or main diagonal. Stoke principle, diagonal. That's what we are referring to. Then it may be the same as The leading diagonal still is that one. This is what I'm referring to, leading diagonal. So, an identity matrix is a square matrix which has ones in the leading diagonals and 0 elsewhere. Such a matrix is that when you pre-multiply any matrix by it, you will still get that matrix back. So we have seen how it works, and for this is an identity matrix and it is always denoted by letter I. So this one we can say identity matrix is denoted by letter I. And if that is the case, we can find that for identity matrix, a square matrix of identity which has 2 by 2, then it is written by I subscript 2. For 3 is I subscript 3. For 4 is I subscript 4. As you move on, that is how we do write them. And if you find that one, you will know this is an identity matrix with the 3 by 3 or a square identity matrix with a 3 by 3 matrix order. So that is how they do happen. In general, let's say that if you have been given M, you may pre-multiply it by identity matrix, or even you do it for, you will find that it is not necessary that we pre-multiply. So that in case you have matrix M, you multiply it by I is the same. If you take that matrix, you pre-multiply it by I, you will still get that one, and that one will still give you whatever we have in here, what we call M. And that is what we are referring to as identity matrix. Let's move on with the determinant of a 2 by 2 matrix. And here, we are going to see how we can find a determinant of a 2 by 2 matrix. The determinant of a 2 by 2 matrix is obtained by taking the leading diagonal, you subtract the other diagonal. And here I'll give you an illustration. In case, for example, let's use an example. Let's say this is my matrix A, having 3, -2, 7, -5. If I need to find the determinant of this matrix, this is what I'm referring to, leading diagonal. Is running from the top left to the bottom right, and the other diagonal runs from the bottom left to top right. This is what I'm referring to our other diagonal. This one is the leading diagonal. So if you do that, you're going to get that this one will be the leading diagonal, that's the other diagonal, but the difference between them is what we are referring to determinant. And it should be with respect to leading diagonal, meaning that you take leading diagonal, or we said it is called also principal diagonal, or you may even call it main diagonal. This one, if we take it, we subtract now the other diagonal, we shall find our determinant. This is what I'm calling determinant. And determinant is abbreviated as DET. It's abbreviated as DET. That is determinant. With the capital or small letter, it doesn't matter. So we are going to get that for this case, our determinant for this matrix, it will be 3 multiplied by -5. I will find 3 multiplied by -5. Then we subtract 7 multiplied by -2. So this one is going to give me -15 minus, into bracket I'm going to have -14. So this one is going to give us -15 plus 14, which will mean that our determinant is -1. So the determinant of this matrix here is -1. I will give you a question and I want you to go and find the determinant of, I want you to find the determinant of 8342. Find the determinant of that matrix, taking into note that we have the leading diagonal and we have the other diagonal. use the procedure which I have used to find out the determinant of this matrix. Find the determinant of Q. Now, we can give it in a general that we can say in general, if we are having a matrix B, which is A, B, C, D with its entry as that, or elements, then the determinant of B is given by taking the leading diagonal, which is A by B, then we subtract the other diagonal, which is C by B, and this one will give us AD minus CB. This is what we refer to as the determinant of that matrix B. So we have seen how we can find the determinant of a 2 by 2 matrix. Any 2 by 2 matrix, its determinant is located using that method, and we have seen how you can find it. Let's see how we can find inverse of a 2 by 2 matrix. For this case, we shall consider two matrices, and one we shall have 3, -2, 7, -7, 5, and another one as Q, which is 5, -2, 5, 2, 7, 3. Now, we want to see what will happen if we take PQ, we multiply P and Q, and also what will happen if we multiply Q and P. So in this case, we shall take 3, -2, -7, 5. We multiply by Q, which is 5, 2, 7, 3. And we shall see if we multiply, we are going to get 5 by 3. 3 by 5 is 15. 15 minus 14. We are going to get 1. 3 by 2, 6. 6 minus 6, 0. -7 by 5, -35. Plus 5 by 7 is 35, so 0. -7 by 2 is -14 plus 15 is 1. So we are finding there is giving us that. Let's see for this case, that is 5, 2, 7, 3. And the other one is 3, -2, -7, 5. So if we do that, we are going to have 5 by 3, 15. 15 plus -14, so that is 15 minus 14, 1. 5 by -2 is 10. 10, -10 plus 2 by 5, that is 10. -10 plus 10 is 0. Then 7 by 3 is 21. 21 plus -21 is 0. 7 by -2 is -14. -14 plus 15 is 1. So in each case, we have found that the answer is the same, and it is giving us whatever we call identity matrix. So we have found if you take PQ, we have found that is equal to QP, and this one is giving us an identity matrix. So we can note that the inverse of this PQ we have found, we said earlier that if we take P, we multiply to Q, that was, for example, A, B, whereby A was the inverse of B. If we multiply in the case that we take P by Q and Q by P, we get identity matrix. That we said is the inverse of each other. For example, here P is the inverse of P of Q, and also Q is the inverse of P. So we can say P is the inverse of Q and vice versa. From what we have worked out, we have seen that in case we have A, we multiply by A inverse, we shall find the same as taking A inverse multiplied by A, and this one will give you identity matrix. If you do that, you will find out that that is what we are referring to, the inverse of a given 2 by 2 matrix, whereby the determinant is equal to 1. Now let's consider a case whereby the determinant is not equal to 1. Let's see what we shall find out. Now here we are going to consider another kind of a matrix, and we shall consider a matrix of 8, 3, 4, 2. That is 8, 3, 4, 2. And also, this is for A. And B, I have another one which is 2, negative 3, 2, negative 3, negative 4, negative 4, then 8. This is for B. For the case of the first one, we saw how it worked. Then this one we need to see. But remember, for the first one we had P, which was 3, negative 2. And then here was negative 5, 7, 5. And Q was equal to 5, 3. This was 2, 7. Remember, for this case, what we got there? And you can see we have said the two were, each of them was inverse of the other. So we can see that from there, as you can view out, look at it keenly. You will find out that here for the first one, the leading diagonal has element 3, 5. The same leading diagonal in Q is 5, 3. So meaning the elements are the same. But the only thing is that they have interchanged their elements. In finding the inverse, the elements in the leading diagonal are interchanged. And those in the other diagonals here, the elements in the other diagonals, we can find out that the elements here are just given a sign, or the sign is introduced in that they negate the sign. For example, if it is negative here, you negate the sign and you find here is positive. So you just change the sign of the other which is in other diagonals. So in the leading diagonal, we interchange the elements, and those elements in the other diagonals, their signs are changed also. Their signs are changed. For a case, if it's negative, you negate again, you will find positive. And if it is positive, you negate, you will find negative. So for the case here, we can easily even tell from here that 8, 2 has been interchanged, in that 2 has been changed to top left and 8 bottom right here. And the other diagonal, we are seeing that is negative 3, negative 4. And we can see this, the matrices have the same elements and is of the same order. So they are not equal, but they have similar elements. They are always in. So what we are going to do here, we shall multiply A and B. And since we have said from the look of things these are inverse, so we shall multiply A, B and see what we shall find. We shall find 8, 3, 4, 2. We are multiplying it by 2, negative 3, negative 4, 8. And we said if it is an inverse, then it should be equal to, if taken 2, negative 3, negative 4, 8, we multiply it by 8, 3, 4, 2. It should be equal. So whatever we shall find there, we shall find is equal. So we can start either from this side or from the other side, and we shall find, if you take 2 by 8, you will find 16. 16 plus negative 12, you are going to find 4. Then 2 by 3, 6. 6 plus negative 6, you are going to find 0. Negative 4 by 8 is negative 32. Plus 32, 0. Negative 4 by 3, you are going to find negative 12. Negative 12 plus 16, you will find 4. So we are finding it will give you 4. In each case, it will give you the same. 8 by 2 is 16. 16 plus negative 12, you are still getting the same thing there. So we have seen, in either case, it's going to give you. But remember what? We said an inverse of a matrix is whereby, if you take, we have seen, for example, here, AB is equal to BA, but this is not equal to identity matrix. But we can say that is not the inverse of that matrix. It's not equal to identity matrix, but we did say that A multiply A inverse or A inverse multiplied by A is equal to identity matrix. But here we can see is 4 times the identity matrix, in that we can factor out 4 and we shall find out that we are having identity matrix out. So from there we can now notice that here, from this situation, 4 was 8 by 2, you get 16, 16 minus 8, 12 you will get 4. So 4 was our determinant. And whatever this person forgot to do by working this way out is that you should divide it by the determinant. So in case you find a 2 by 2 matrix and you need to find the inverse of a 2 by 2 matrix, whereby the determinant is not equal to 1, what you should do here is find first the determinant, find first the determinant of that matrix. After getting the determinant of the matrix, divide it or find 1 over that determinant. So in case you find your determinant is 0, sometimes you may work out, for example, our first matrix was A and we had 8, 3, 4, 2. And if you work out and find determinant is 0, for example, if determinant is equal to 0, then that matrix has no inverse at all. So you read it that way. It has no inverse. So if you do that one and you find the determinant is not equal to 0, the determinant is greater than 0. For the case, it may be greater than, the determinant may be greater than or less than 0. Actually, let me just involve here. May be greater than 0 or less than 0. So 0 may be on both sides. So determinant may be negative form or positive form. So it may be greater than 0 or negative 0. So if you may find that your determinant is not equal or is greater than 0, then what you should do to find the inverse, you find the determinant of that matrix. For the case of A, the determinant is equal to 8 by 2, the leading diagonal. Then I subtract the other diagonal, and I will find out this one is going to give me 4. After finding that, then you are going to take 1 over that determinant, of which now will be, we are going to find the A inverse actually. So we need to find A inverse, of which will give us B. So we shall find 1 over that determinant, which is 4. And then from this matrix, what we are going to do, we interchange the elements in the leading diagonal. So meaning if here it was 8 and here 2, we interchange. This one moves upward direction and this one moves to that position. So it will be 2, 8, and the other one in the other diagonal, this 8, the 8 and 4, we do negate or change the sign. It was positive, now we change to negative 3 and negative 4. Then whatever we shall do here, if we do that one, we shall find the inverse of that matrix, and it shall be a quarter multiplied by 2. You are going to find out is a half. Here it will give you negative 3 over 4. Here is negative 1. Here is 2. So this one is now the inverse of the matrix A. The inverse of this matrix here. So that is what we can refer to inverse. This one was not the inverse, because we said if you find the inverse of any kind of matrix, if you take that inverse, you multiply by the matrix, or the matrix you multiply by that inverse, should give you identity matrix, not 4 times that identity matrix. So that is now the inverse. And you have seen how we can find the inverse of a given matrix, considering that that matrix is greater than 0, and if it is not greater than 0 or less than 0, then we can say that matrix is equal to, that determinant of that matrix is equal to 0 and has no inverse at all. Let's see in our next session how we can solve solution of simultaneous linear equation using matrices. But before that, I will give you a general. In general, if x equals to PQRS, if x equals to PQRS, then x inverse will be found by taking 1 over the determinant of x, that of x. Then here we interchange s and p, and q will change the signs. We change the signs of q and r, which are in the other diagonal. Whatever you will be finding here will be x inverse. And remember, the determinant of x, we said, shall be the leading diagonal, which is ps minus qr. So that is how we do find the determinant of a given matrix. If it is 0, if the determinant is 0, know that that one has no inverse. Let's now see how we can solve simultaneous equation using matrix. So we are going to see simultaneous linear equation using matrix, and we shall consider an example of 3x plus y equals to 7, and another one as 5x plus 2y equals to 12. We are going to consider these two examples. Is it? Yeah, 7, not negative 7. We are going to consider these two equations. From here, we need to form a matrix in which, if we solve it, we shall find whatever we are seeking. And for that case, we can see we having two unknown here, that is x and y. We need to determine what is the value of x and what is the value of y. Since we have that linear equation here, and this one is another linear equation, you can solve this linear equation using either simultaneous method or substitution method or even graphical method, and you will find the value of x and y. But here, we need to find the value at which, for instance, if we plot this one on the graph, you will find that the line of this 3x plus y equals to 7, which may be y equals to 7 minus 3x, you will find it will cut the line of the other 5x plus 2y equals to 12. At the point where they cut each other is where we shall take the value of x and y. But for this case, we are now going to use a matrix method to solve this equation. And you will use any kind of a problem. You will use a matrix method to solve any kind of a problem that may involve simultaneous equation. For example, for this instance, we need to form 3 matrices from these 2 linear equations. And here we are going to form the first one will be what we refer to as a matrix of coefficients. So we shall form first. Here we are going to take 3, 1. Those are the coefficients of x and y in the first equation. And in the next equation, we are going to have 5 and 2. That are the coefficients of 5, the coefficients of x and y. From this, we know that we are proceeding with the x and then y. So what we shall do, we shall form now a matrix of our variable, which is x and y, and then we shall now form a matrix of constants. Matrix of constant is what we shall be having as the result. So we shall form another matrix here, which is 7, 12, and that is the matrix of constants. So from there, we cannot solve this one as we were solving before we reached here. The way we were solving multiplication of matrices, so we can use that method to solve this one here. So we shall do this. Since here I have told you this one here, we call it as matrix of coefficient. This one will be matrix of variable because this is what we are going to say. And this one here is what I'm referring to as matrix of constant. And we can solve by taking 3 multiplied by x. Someone may ask, why don't we just put the y's below and x below? We write it the way they are, then we proceed with what we have here. If we start with the y, then y will be at the top. But if we start with the x, in both cases, then we make them to be that way. And if it were, here was 2y, and here 5x, then we could just write in terms of, we shall change the way we need it, maybe to avoid that confusion. You will interchange to make that like terms are both on the same sides. So it will be 5x plus 2y. And if not, if you cannot confuse easily, you just write where the x's will be. So you start with the first, you know, is for x, and the second one is for y. So you start that way, and you move on and you write that way. So you can now multiply and find the value of x and y. Here we shall start with 3 multiplied by x. We shall find 3 by x is equal to 3x. Actually, this is a 2 by 2 matrix. This is a 2 by 2 matrix. And this one is a 2 by 1. This one is also a 2 by 1. So we can see they are compatible, meaning we can multiply. And our result is 2 by 1. Actually, that's the truth. So we need to find the value of x and y. And from there we are going to take 3 by x, we shall find is 3x plus y. It shall give us what we have in there. So what we are going to do here, since we have seen, if we do expand, we are still going to get the same linear equation. Here what we are going to do, we are going to make sure that we multiply by the inverse of the matrix of coefficients. So if we multiply by the inverse of the matrix of coefficient, we shall find that here we are going to have, if we find the inverse here, we shall have 3 multiplied by 2 is 6. Then 5 by 1 is 5. So if you subtract, you will find 5. You are going to subtract 5, so it's giving us the determinant as 1. And if the determinant is 1, there is no need of finding 1 over the determinant. So we shall just interchange the leading diagonal. That is 2, 3. And this one will be -1 and -5. So this is the inverse of this matrix. So we are going to pre-multiply it on both sides. That is 2, -1, -5, 3. We pre-multiply on both sides, so it will be 3, 1, 5, 2 is equal to, actually here is x, y, then is equal to, for this side we also pre-multiply, -5, -1, 3, and here we multiply by 7 over 7, and this one is 12. So we are going to have that case. So we are going to multiply the two matrices. We are going to multiply and find out what we shall get. If we need the variable of here, we are going to take 2 multiplied by 3, we shall get 6. 6 subtract 5, you will get 1. 2 by 1 is 2. 2 minus 2, you are getting 0. -5 by 3 is 15. 15, -15. -15 plus 15, you will get 0. -5 by 1 is -5. -5 plus 6, you are getting 1. So we are finding this side is giving us that way, and this one will be xy is equal to 2 by 7, 7 is 14. 14 minus 12, 2 by 7, 14. 14 minus 12, you are getting 2. Negative 5 by 7 is 35, negative 35. Negative 35 minus negative 35 plus 36, you are getting 1. Negative 35 plus 36, you are getting 1. So that is what we are getting. So if we do out this one further, you will get 1 by x is x, x plus 0 is x. So x, you will find x, and then 0 by x is 0, 0 plus y, you are getting y. So you are finding this one is equal to 2, 1. So meaning the value of x is equal to 2, and that of y is equal to 1. Using even the graphical method, you will find out the value of x is equals to 2, y equals to 1 for this linear equation. The same will apply if you use simultaneous equation, or if you use substitution method, you will still get the same answer. So with that, we can say, if you have been issued with 2 simultaneous linear equation, maybe it a solution or a problem which requires a solution, maybe it's a numerical problem dealing with the cash price, maybe whatever you may encounter. What you do, the first thing, form the 2 linear equation, the 2 simultaneous linear equation. After forming, form the matrix of coefficient, matrix of variable, and also form the matrix of constants. After forming that, you now come on and find the inverse of the matrix of coefficient. So if you find the inverse of the matrix of coefficient, then the next process, you pre-multiply each side by that inverse of the matrix of coefficient. For our case, we pre-multiply by this inverse in this method, and you find out that you will find it will give you on the left hand side, you will have an identity matrix together with the matrix of your variable. So it's equal to whatever you will have found after calculating that. So we found that. And if you go on further using that identity matrix, you will find you are remaining with your variables or matrix of your variables, which is equivalent to matrix of constant, which is simplified. So you will find that x is equals to 2, y equals to 1. And for your case, you will find your corresponding answers. With that example, we will see how we can work out another one. For example, I want us to work one which depends on negative, which is subtraction. Let's work out x plus y equals to 5. And another one is 3x minus 2y equals to 0. Here, the first thing what you do, you form the matrix of coefficient, and if you form the matrix of coefficient, we are going to have 1, 1, 3, negative 2. And matrix of variable, we are going to have x, y. And matrix of constant is 5, 0. So as we can view, this is a 2 by 2, and this is a 2 by 1. This is a 2 by 1. So meaning they are compatible, so we can multiply. And then from there we can do this. We go on by finding the inverse of the matrix of coefficient. And inverse, we said you first find the determinant, that is from the leading diagonal, which is negative 2 minus the other diagonal, which is 3. So if you do that, you're going to get negative 5. So if you need the inverse, you find 1 over the determinant, which is 1 over negative 5. And then whatever is in the matrix of coefficient, you just interchange the leading diagonal. So it will be negative 2, 1. And the other diagonal, you change the sign. So it's negative 1, negative 3. And we shall find out that we are going to have negative 1 over 5. Multiplied by that, you are going to have positive 2 over 5. That one will give you positive 1 over 5. And this by this is a scalar quantity, so if you multiply by 3, it is going to give you 3 over 5 because negative and negative is positive. And here we are going to have negative 1 over 5. So that's what we find as the inverse. So pre-multiply both sides by the inverse. And if we pre-multiply both sides by the inverse, we are going to get 2 over 5, 1 over 5, 3 over 5, negative 1 over 5. And this one, if we pre-multiply by 1, 1, 3, negative 2, x, y, we shall find the same should be done on the right hand side, which is 2 over 5, 1 over 5. And here 3 over 5, negative 1 over 5. And this one should pre-multiply by 5, 0. So whatever we shall find is the values of x. Since we have known this one is the inverse of this, then it means we shall have 1, 0, 0, 1 and x, y. So this one is going to give us, so if we pre-multiply here, we are going to get this one will give us 2 over 5 by 5 is 2 plus 0, we shall get 2. And then the denominator will be 3 over 5 by 5 is 3. 3 minus 0 is 3. So we shall find that. If you work out on this, you are going to remain with x, y. And the right hand side is going to give you 2, 3 as it is. So meaning that the value of x is equal to 2 and the value of y is equal to 3. So this is how I find it much more easier to solve two simultaneous equations using matrix than any other kind of method. So we have seen how it works, but sometimes you will find out that the determinant of the matrix of coefficient, sometimes you may find out that the determinant of the matrix of coefficients is not equal to 1 or negative 1 and above, but is equal to 0, such that the determinant of the matrix of coefficient equals to 0. For a case, let's consider two lines, for example, 2x plus 4y equals to 6, and another one 3x plus 6y equals to 5. And another one, we consider two simultaneous equations, that is, we are having x minus 2y equals to 2, and this other one is 2x minus 4y equals to 4. So we shall first consider this one, and if you work out the determinant of this one, let's see first. We can form the matrix of coefficient. Our matrix of coefficient, we are going to have 2, 4, 3, 6. And then matrix of variable is x, y, and that of constant is 6, 5. So after forming that, we can find the determinant of the matrix of coefficient, and we shall find the determinant is equal to 12 minus 12, which is equal to 0. And remember we said that a matrix which gives us the determinant as 0 is we refer to that matrix as a singular matrix, but it has no inverse. So this one has no inverse at all. So meaning that we can't solve this one using matrix method. And with that, it gives us that if that one was to be drawn on a Cartesian plane, you will find that there are two linear functions. These are two linear functions with the one side running this way, and this is cutting a y-axis at 5. Not at 5. Actually, it's at 5 over 6. So it is cutting y-axis at 5 over 6. And the other one here, this is of 3x plus 6y equals to 5. So cuts that y-axis at 5 over 6. And the other one cuts y-axis at 3 over 2. So it will be 3 over 2, that is 1.5. So you will find it is cutting at approximately this point here. This is equation of 2x plus 4y equals to 6. And this point here is 3 over 2 or 6 over 4. So we can find that the two equations, they are parallel to each other. There is no way they can cut each other. The equation above is parallel to the equation which we have on the denominator, meaning that this equation here is parallel to this. They are totally parallel, meaning that the solution there can't be determined. They have no solution. So the lines are parallel, therefore they have no solution. But we can find out that using the others, we can find, for these parallel lines, we have said they have no solution using matrix method, so we can find any solution there, even with the graphical. So let's consider the other equation, whereby it's a double of the first. In that, we are going to have matrix of coefficient. From this one, we are going to have as 1, negative 2, 2, negative 4, and matrix of variable is x, y, and matrix of coefficients is 2, 4. So if we work out this one, we are going to find that the determinant here is equal to negative 4 minus 4, and this one is giving us 0. It's giving us 0. So meaning the same, we can't work out the inverse of that matrix of coefficient, and with that we can find the solution to that two simultaneous equation. And if we have that, you will find out that if you draw a Cartesian plane, that is xy, considering that is xy, you will find that those two equations merges with each other, in that you will find you will draw the first equation, and then the second simultaneous equation will pass through each point the first equation passed. So it will be, both of them will be in this direction, and that one is at point where y equals to 1. Where this point is y equals to 1, they will all pass at that point, and you will find that the first equation here will be x minus 2y equals to 2. But if you go on and draw the next equation here on a graph, you will find that it will still pass through the same points of that equation, and we can say it still equals to 2x minus 4y equals to 4 is still the same. So with this, we can say that the solutions of these equations are infinite. They are infinity. We can't tell because they merge, meaning that every point on the line of that equation is the solution of that given two simultaneous equation. With that, we have come to the end of matrix in form 3, and I think the topic has been interesting.